temperature is actually the same thing that we went over 2 weeks ago in lab. So it should be almost no new material. So it's kind of like a review day. But bad news is we're now a week since the research assignment, and I don't even have an approved protocol from any group. Meaning that no one's even collected
I've been posting to
I know.
a tiny speck of data. Nobody's even collected. Which means you have approximately 5 days to perform at least probably 2 trials, providing nothing goes bad. And that's not including I'm out of town on Tuesday. Gotta leave early today. You guys are running out of time, and I have seen people fail the presentation. So don't sleep on this presentation. It's actually really helpful for your grade if you do it. Send me your protocols so I can approve of them. I know Lance has been communicating with me, and he's finally got something that resembles what we should be doing, but we haven't got it approved yet. So, yeah. Any questions on that before we get going?
As far as the protocol, you need everything from the intro all the way down to the conclusion before we can even start the trials.
Nope, I just need bullet points, the general
Methods.
protocol for the day.
Okay.
That way, one, I know that we can do all those things and you know what you're collecting, and we're not just jumping into it blind. And the other thing is I gotta prepare stuff. Like if you need the chamber set to a certain temperature, sometimes it takes longer than other times, and stuff like that. Or if I need to calibrate a machine or something. But yeah. All right. So this is where you guys left off-ish. You guys kind of went back through these things, right? On the online course. Okay, this looks really similar to something I showed in lab. Do you remember what it looks like? What I showed in lab? Very similar. Do you remember a figure that I showed that looks really, really close to that? It's like one slight difference.
Vaguely, yes.
Do you remember that?
Sure.
What's the difference? What is the thing that I posted that's a little different than that?
Your colors are different.
The colors were different, yeah. Not really, but kind of. There was something right here. Otherwise, it's basically the same graph.
Pressure is there.
Huh? There was the guy that was doing like the flex thing.
Oh, yeah.
It's the same figure. It's the exact same figure. Okay, so what is this figure telling you? You guys are basically going to teach this class since you already heard all this stuff.
High blood pressure.
Yeah, it's basically the pressure gradient is what's going to ultimately drive flow. The pressure gradient is ultimately what's going to drive flow throughout the systemic circulation. Okay, what is this graph saying? This should be from last week. Or from last lecture.
Pressure is controlled going down.
Okay.
And pulsing and the large arteries, arterioles.
So the biggest drop in pressure you'll typically see is the arterioles. Okay? Because we're gradually getting smaller and smaller, branching out, smaller and smaller. Okay? In the large arteries, it typically hovers around 120/80. You all knew that. And then it goes down here all the way until it's almost 0. Why is it almost 0 in these large veins? Why would pressure almost be 0 in the large veins?
There's no constriction. It's called your blood reservoir.
Yeah, so it's a capacitance thing. It's really stretchy. So if you fill it up more, it's probably not going to make a whole lot of extra pressure going on. It's kind of like a water balloon, I guess. Really, a lot of compliance. Okay, and then this is kind of where we're picking up today. And so there's 2 equations, but I want to rearrange them a couple different ways so that you guys can follow along. So this is the equation you guys are probably bored with by now. Cardiac output times systemic vascular resistance, total peripheral resistance, something like that, right? Seen that 100 times. And then the other one, fixed equation, which is VO2 equals what? Fick equation, remember this at all? Times cardiac output times the AVO2 difference. Nobody remembers this? We'll go over it. Okay. How can we rearrange this? What are some ways we can rearrange that equation? Ohm's law or Darcy's law, either way. What ways could you reconfigure this to maybe solve for a different variable?
You do cardiac output equals arterial pressure over peripheral resistance.
Yeah, we could do this.
Free flowing breakup cardiac output. Heart rate stroke volume.
Yeah, we could break that up into stroke volume part, right? Okay, what's another way we could do it? Anyway, yeah. What's another way we can rearrange this equation? Okay.
MAP over CO.
Equals what?
MAP over CO.
Okay. Okay, so keep these in mind, because in terms of what we're talking about today is oxygen delivery or blood flow through an organ. We may be talking about that. Okay? And in terms of blood flow, cardiac output will always kind of be our way of saying flow. Right? And we're going to see how that changes in a bit. And so for this one, cardiac output, okay, is the delivery of oxygenated blood. AVO2 difference is the extraction. And so this will jog your memory. AVO2 difference is analogous to me having a Super Bowl party and making Little Smokies. And you don't eat Little Smokies because you're foreign. But Little Smokies, right? We had the crock pot full of Little Smokies, barbecue sauce, soupy stuff. They actually put grape jelly in it, too. Yeah, you can't taste it, but it's good.
It's really good.
It's really good.
It is.
He's a big fan.
Really bad for you too, but really good.
Sure. I don't know what's in those little things. I think they're from miniature pigs. The Little Smokies. Have to be. Like baby pigs. It's cool. So assume that big crock pot of Little Smokies is full of little bitty hot dogs, right? Let's say there's 100 of them. And let's consider that the same thing as maybe oxygenated blood. Okay, there's a lot of oxygen in blood, a lot of Little Smokies in my crock pot. All right, if I walk around on Super Bowl day and everybody just came from a big nacho fest, and I walk around and then I take stock of what's in my Little Smokies in my little crock pot, maybe I'll still have 90 in my crock pot because nobody ate my Little Smokies, right? And so in that case, my A minus my V, which is Venus return, so when I returned to the kitchen and counted how many Little Smokies I had 90. My AVO2 difference is 100 minus 90. So AVO2 difference is small. There wasn't a lot of extraction of Little Smokies at my Super Bowl party. Okay, AVO2 difference is extraction. But let's say you guys are starving and I have the same Super Bowl party, same 100 Little Smokies with Wendy's secret recipe, and we walk around and it's got 100, and I come back, Venus return, I return back to the kitchen and look, and there's only 20 Little Smokies left. Okay, 100 minus 20, 80.